Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to go over how to name ionic compounds, and I'm going to go over a bunch of examples for you. So let's get into this. So the key to naming ionic compounds is really this simple. If you know the name of each ion, you are literally just putting the names together for each ion, and that's the name of your compound. So you can imagine the importance of knowing the names of the ions itself. So let's show how it's done. So here I have MgO. So I need the name of each ion. So here Mg, that's a main group or representative metal or element. And so that's going to be, again, just the name of the element itself. So your positive metal ion is just going to be the name of the element. So here it's going to be, magnesium, right? So it's going to be the first element's name, magnesium, or first ion's name, magnesium ion, right? We won't write the word ion, we'll drop that. And then what is the second name? What is the name of the second ion? Well, it's a monatomic ion. It's oxygen. It comes from, it's a non-metal, right? So we know because of the fact that ionic compounds are neutral, the second ion has to be negative. So how do we name this one? Again, it's going to be the name of the element where you drop the ending and add IDE. So oxygen becomes oxide. And there's the name of that compound, magnesium oxide. So we're dropping the word ion for each of the separate ions and putting them together to form the name of the compound itself. So let's look at B. So B, we have CO, which is cobalt, my favorite element on the periodic table for obvious reasons. And then we have Cl for chlorine, right? So positive, negative. So this is a metal, right? It's also a transition metal. So we need to be aware of the Roman numeral. So when we name this metal, it's going to be the name of the element. So cobalt. This is a transition element, so it's going to have a Roman numeral for the charge. So we need to know what the charge is. And so this is where you're going to have to balance the charges, and you got to know one of the charges. So you should know the charge on the chlorine atom for that chlorine ion. So here, what charge is chlorine going to have? Well, it's in group 7, so you should know it's going to have a -1 charge because it's going to gain 1 electron to be like the noble gas. So we know, I'll write it down here. So we know chlorine is going to have a -1 charge. So we have 2 chlorines, and we know that the compound itself has no charge. It's neutral. So if I have 2 negative chlorines, then I'm going to have a +2 charge on my cobalt, right? Because I have 2 of these, I need 1 cobalt. I have 1 cobalt, so that means that there must be a 2+ charge on the cobalt to balance out the charge. So that means that the Roman numeral is a 2. So this is cobalt 2. And then now I add the name of the second element or second ion. In this case, I have chlorine. It's a negative ion, as we can see here. Therefore, we're going to drop the ending, add IDE, and it becomes chloride. And there's the name of CoCl2, cobalt 2 chloride. It's that simple. Okay, let's go on to the next one. Here we have Fe and O. So again, Fe, that stands for iron. So the name of your first element is going to be the name of the element, or the name of the first ion is going to be the name of the element, iron. And once again, iron is a transition element, therefore it's going to have multiple charges. It's not one of those exceptions. Remember, silver and cadmium and zinc are exceptions. Those will not have Roman numerals because they only have one charge. Iron has multiple charges, so it's going to have a Roman numeral. But we need to figure out what the charge is on the iron. So what we can do is we have 3 oxygens. We know the charge on oxygen. You should know at least one of these charges. Since we don't know the charge on the iron just yet, we have to go to the negative ion, and that's oxygen. Oxygen is in group 6, so you should know it has a -2 charge because it's going to gain 2 more electrons to be like its closest noble gas. So it's got a -2 charge. So if I write this down here, I have 3 oxygens, right? And I have 2 irons. So the total charge here for the negative is a -6. So to balance out the charge, I need a total of a +6 charge on my irons. Well, if I divide that up evenly among my 2 irons, that means each iron should have a 3+ charge. I should put the charges after the number. I won't get into the technical reason for that, but there's a reason. So now I know the charge on my irons, so I can write the Roman numeral. So it's going to be 3. So this is the iron 3 ion. And then oxygen is the second ion. Again, it's a negative ion, so I'm going to drop the ending and add IDE. So oxygen becomes oxide. And so I add that. And that's the name of Fe2O3. This is also known as rust. Okay, next we have LiCl. So our first ion is Li. That's a metal. This is in the first group. And so this is going to be just the name of the element. So Li is lithium. It is a main group element, so there's not going to be it's not going to be a Roman numeral. Again, there are 2 exceptions. There's lead and tin. They will have Roman numerals, even though they are main group elements. But this is not an exception, so it's just the name lithium ion. So we're going to drop the ion. And then the second name, Cl, again, same as before. It's going to be chlorine, drop the ending, add IDE because this is a negative ion. So we have to have the IDE ending for our monatomic ions. And so again, it's going to be chloride. So lithium chloride is the name of that compound. Next, these next 3, we're getting into polyatomic ions. Now, the rule is the same. If you know the name of your ions, just put the names together and you've got the name of your compound. When it comes to polyatomic ions, however, you need to memorize the names because the polyatomic ions have their own names that you just need to memorize. You don't change any endings, you don't do anything to them. You just got to memorize them and put them together. So NH4. So NH4 and we have NH3. These are 2 polyatomic ions. You should recognize NH4 as the ammonium ion. It has a +1 charge on it. And so the name is ammonium. So we're going to add ammonium as the first name. So the ammonium ion. And then the second ion is NH3. Oops. NH3. No, that's not right. Hold on a second. Let me double check. That's supposed to be NO3. I was going to say that's not even an ion. NH3 is not even an ion. It's ammonia. So NO3, that's much better. So NO3 is nitrate. So it's the nitrate ion. Don't confuse this with nitrite. NO2 minus is nitrite. So NO3 has a -1 charge on it. Again, you have to memorize these. There's no other way. So I do have a couple of videos that will help you memorize these based on certain patterns. So if you know the patterns, and it'll help you to memorize certain ones, and then based on those, you can kind of figure out the rest. So check out my videos on polyatomic ions. But this one is nitrate, so I'm going to write nitrate. And there's the name for this compound, ammonium nitrate. Next, we have Cr2SO43. Again, we have a polyatomic ion here. So again, you got to know this name here, but we'll get to that in a moment. Cr, that's chromium. Again, the first one, we have a monatomic ion here. It's a metal. It's a transition element. And so we would expect a Roman numeral. So we're going to write Cr, that's chromium. So we're going to write chromium. Okay, next we have to figure out the charge on this so we can write the Roman numeral. So we need to start with sulfate. So let me write that over here. Oops, let me give myself some room. Let me see here. Yeah, I'll write it over here. So I have SO4, there's a 2- charge on the sulfate ion. And notice the 3 on the outside of the parentheses, that means that I have 3 of these sulfates. So if I write sulfate 3 times, once again, I have a total of a 6 negative charge or a -6 charge. And if you look here, I have 2 chromiums. So I have Cr and Cr. That means that, again, there must be a balanced charge. And so I have a 6+ charge total to balance out. So that means that each chromium, if I divide up the charge amongst the two, then they should have a 3+ charge on both. So now I know the charge on my chromium, and then that's the Roman numeral 3. So Roman numeral 3, I have chromium 3 ion, and then I just add the name of my polyatomic ion here, which is sulfate. And that is the name of Cr2SO43. Last but not least, we have again NH4, HCO3. So again, NH4, polyatomic ion, has its own name. You got to know it. You got to know the charges too. There's a -1, there's a +1 charge. I messed up. There's a +1 charge on NH4. So again, this is ammonium. And then this bad boy right here, HCO3. Notice that one of the ways you can remember things like this is this polyatomic ion. If you know that one, that's carbonate. That would have a -2 charge on it. And if you recognize hydrogen, hydrogen as an ion would have a +1 charge on it. So if you think of it in terms of H plus with CO3 2-, then the plus and the 2- would cancel each other out, and you have a -1 charge. And so what is this called? Not carbonate, but hydrogen carbonate. So you see how if you know the patterns, then you can figure out what the names of your ions are for the polyatomic ions. So again, check out my video on this. Okay, so this is hydrogen carbonate. So I'm just going to write down hydrogen carbonate. And there you go. This is called ammonium hydrogen carbonate. And that is how you name your ionic compounds. I hope you enjoyed this video. If this was eye-opening, mind-blowing, if you liked it, then please by all means share the video, like the video, hit that like button over there. Make sure you subscribe to my channel, hit that notification bell. And when you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. If you have a topic you would like me to cover, or if you have a problem or question you want me to answer, then please let me know. I would love to do that for you. Thanks for joining me and have a great day.